we've created our own micromolecular suicide squad.
Yeah.
But we haven't, like, there's still the concerns, but they are still the suicide
Yeah,
squad.
they're still the suicide squad.
So this story is coming out of Columbia Engineering. Researchers at Columbia Engineering have built a cancer therapy that makes bacteria and viruses work as a team.
It's combining the virus, which is really good at killing the cancer cells. The virus is becoming like the Greek soldiers inside the Trojan horse.
Yeah.
And the bacteria becomes a Trojan horse. Okay, because the bacteria has an easy time getting into the center of the tumor, right? They got these mice models that sort of mimic the small cell lung cancer, okay? 100% survival rate.
Jesus.
Okay. I mean, we're far away from like
Sure.
FDA approval,
100%.
right? There's lots of concerns. Obviously, like I talked about mutation just now, right? Like
Yes.
what's stopping this virus from mutating into like its original version of where like I hate it,
Yeah.
right? So yeah,
It's like we've created our own micromolecular suicide squad.
yeah.
But we haven't, like, there's still the concerns, but they are still the suicide
Yeah, they're
squad.
still the suicide squad. So like in order to get to actually like human trials, because right now they've done it on mice and they've done it on in vitro sort of human cell lines and things like that. In order to get it to sort of FDA approval, we have to first of all mitigate the risks.
Yes.
One of the ways that they're actually doing it, and they described it in this paper, is instead of a single nucleotide mutation that will take the virus and put it back into its wild type, which is the part that we don't like. They made it 2 mutations. Okay. So what that means is now, like, you know, if the probability of like going to a mutation was 1/100, now it's geometric. So it's 1/100 squared. So 1/10,000, which is like obviously way better than 1/100.
Right.
You can imagine like doing this for multiple single nucleotide mutations. We also need to test it on higher order organisms, right? Right now we did it on mice. We need to like start graduating and slowly going towards human beings.
Yes.
But I think it's extremely promising.